control procedures that were performed. Think of the formulation record as a recipe that must be followed exactly. It's a list of the exact ingredients and procedure the compounder must use to produce a consistently safe and effective preparation. Labeling refers to, you guessed it, the label on the bottle, tube, or other package containing the prepared pharmaceutical. Labels and what information they include are guided by state and federal regulations. You ever wonder what all that stuff listed on your prescription bottle means? There's a reason for such pieces of information included on the label. Some obvious ones include the pharmacy name, address, the phone number, the prescription number, and directions for use, the name and quantity of active ingredients, and the patient's name. But you must also include the preparer's name or initials and a beyond use date per the institution's standards. Sometimes auxiliary labels will be attached that provide extra instructions for the patient on how to store or use the medication, like refrigerate or shake well.
Proper dating of a compounded preparation should happen at the time of labeling and must follow the guidelines of the United States Pharmacopoeia National Formulary, or the USPNF, because stability of the formulation may change once the ingredients are added together. Stability is defined as the extent to which a dosage form retains the same properties and characteristics that it possessed at the time it was manufactured. Drugs may become unstable in storage or due to mixing with other ingredients, which is why proper dating procedures are critical. There are two dates in particular that are important to note when compounding pharmaceuticals: expiration date and beyond use date. The expiration date is determined by the stability of the drug and is required on commercially manufactured products. Most expiration dates are given in years. Beyond use dates are used for compounded preparations and are generally given in days or months. A 30-day expiration is often used for compounded preparations, but the expiration date could be even sooner, depending on the nature of the ingredients, the concentrations of active ingredient, diluents used, and the packaging. All of these factors can change the chemical properties of the compounded preparation. Once a manufactured drug is removed from its original packaging, its expiration date changes. Environmental factors such as light, temperature, humidity, and oxygen concentration can all affect the active ingredient of a preparation. The new beyond use date should be in accordance with the manufacturer's approved labeling or other sources as noted. You'll do a lot of hands-on work with your instructor when calculating beyond use dating later in your studies.
Now that you've worked to prepare a safe and effective compounded pharmaceutical, chosen the proper packaging, and labeled it accurately, there's one last step which, if not performed properly, could undo all your careful work. Storing medications properly is one of the most important factors in ensuring the longevity and stability of medications, and it's vital to follow the manufacturer's guidelines when storing commercially available medications. When storing compounded medications, however, it gets a little more complicated. You must store the preparation according to the strictest storage requirements of the ingredients used to prepare the drug. Containers used to store medications should be light resistant, tightly sealed, and protected from contamination. All materials used in compounding should be stored and packaged according to the manufacturer's labeling, the National Association of Boards of Pharmacy, or the USPNF guidelines. Storage requirements are important to follow because they help prevent contamination or decomposition of chemicals and materials. All ingredients must be stored on shelves, marked with the date of receipt, and rotated so that the oldest is in front. Ingredients should not be used beyond their expiration date. If a specific temperature requirement has been indicated for storage, then it should be followed as well.
Okay, so we've learned about dosage forms and the basic equipment used when compounding. Now let's take a look at the most common non-sterile compounding techniques in action. You've chosen the correct formulation record for the preparation to be compounded, gathered all your ingredients, necessary equipment, and final package. So what's next?
First and foremost when compounding, proper hand washing. Normal bacteria typically do not affect a healthy person, but can cause extreme harm to a patient who is already sick. Follow this procedure to properly wash your hands. Remove all jewelry, including rings, bracelets, and watches. Use warm water and let it run the entire time you're washing your hands. Wet your hands and wrists up to your elbow. Scrub hands, nails, wrists, and forearms thoroughly for at least 30 seconds with a brush, warm water, and appropriate bactericidal soap. Scrub your palms, the backs of your hands, between your fingers, each one individually, under your nails and around your cuticles. Rinse your hands thoroughly, holding your hands upward toward the running water so that the dirty water and soap runs toward the elbows and not the hands. Hold fingernails under running water to make sure they are properly rinsed. A touchless dryer system is preferred, but if that's not available, use a clean, lint-free towel to dry your hands and use the same towel to turn off the water. When compounding, wear clean clothing appropriate to perform your duties. To prevent contamination of compounded preparations and to protect workers, protective apparel such as head, face, hand, and arm coverings should be worn as necessary.
It's essential to ensure ingredients are weighed or measured 100% accurately. If not, the patient may be harmed. 3 types of measures are used in compounding. Metric measurements are based on multiples of 10. The basic metric units are grams for weights, liters for volume, and meters for length. You'll work mostly with metric measures in the pharmacy. You are probably already familiar with the apothecary system of measurement, which is calculated using ounces, pints, quarts, and gallons for fluid measurements. These can be found on stock bottles and prescriptions. The avoirdupois system is strictly for weight measurements. The grain is the basic unit. In general, bulk chemicals and over-the-counter pharmaceuticals are measured with this system.
The Class 3 balances that we discussed earlier have weights in both apothecary, ounces, and metric, grams measurements. When using this balance, it's important to note that it has a variance of 6 milligrams. Now, this means that 6 milligrams can be added or removed from a pan before the pointer will move 1 division. The smallest readable amount is 10 milligrams and is known as the readability. The largest amount is 60 grams or 120 grams, depending on the scale size, and is called the capacity range. Be sure to cover both pans with weighing paper or boats when using this balance. A clean weighing paper or boat should be used for each new ingredient, and the balance must be readjusted after a new weighing paper or boat has been placed on each pan. For the most accurate reading, be sure to lock the balance before adding or removing weight from either pan. Only use the balance on a level surface and a draft-free area.
When measuring, always select the smallest container that will hold the desired amount, because this will minimize the percentage of errors. The closer the container is to the amount measured, the more accurate the measurement reading. For oily or viscous liquids, choose a syringe if possible, because the liquid will tend to cling to the sides of the container and cause long drainage times and ultimately poor transfer. It is very important to remove all the liquid possible once it is measured. So pour carefully into the calibrated container and do not allow the liquid to run down the sides. When compounding, always use calibrated devices to measure. Never use household measuring tools, such as teaspoons or non-calibrated droppers or oral syringes. Never measure from a stock bottle or a prescription bottle. Always read the meniscus and allow time for the liquid on the sides to reach the middle before taking the final measurement. Once the final preparation is compounded and ready for the patient, provide them with a calibrated oral syringe or medicine dropper. Household teaspoons are not accurate because of the viscosity or surface tension of the preparation.
Some call the action of a mortar and pestle grinding or pulverizing, but the actual term is triturating. Trituration is a process by which particles are reduced to fine granules in a mortar with a pestle. This can be crushing or pulverizing a single powder, mixing equal amounts of more than one powder, or mixing powders of unequal quantity.
Spatulation is the process of mixing ingredients together with a spatula. Typically, the ingredients are spatulated on an ointment slab or parchment paper. This method does not reduce particle size, so the powders must already be very fine and uniform.
Levigation is the process by which very small amounts of a levigating agent, such as mineral oil or glycerin, is added to a powder to form a viscous paste. A paste is gradually formed by adding drops of mineral oil one at a time and spatulating the ingredients. Levigation is used when a dry ingredient must be compounded into an ointment base. The dry ingredient is generally levigated to allow for a more even distribution of the particles in the ointment base. It's important that the levigating agent not interact with the active ingredient. Levigation will reduce particle size because ingredients may also be triturated or spatulated.
Geometric dilution is used to evenly triturate two or more ingredients that are unequal in quantity. First, weigh the ingredients. Next, place the ingredient of the smallest quantity into the mortar and add the same amount of the larger quantity ingredient. Triturate until homogeneous. Next, add an approximate amount of the larger ingredient to the mortar equal to the quantity of the previously triturated ingredients and triturate until homogeneous. Continue this process until all of the ingredients are evenly mixed. If working with multiple ingredients, continue this process by adding the smaller quantity ingredient to the mortar and triturate until homogeneous. It is essential that the mixture be homogeneous because this is the only way to ensure even and consistent delivery of the final preparation.
We touched on the commonly used punch method of filling capsules a little earlier. Here's how it works. Count out the number of capsules needed, remove the capsule tops, and place them on the side. On an ointment slab or sheet of parchment, organize and level the ingredient powder to a height approximately 1/4 to half the size of the empty capsule. Holding the capsule, punch or firmly press the capsule into the powder. To aid in packing the capsules, rotate the capsule body slightly as you pack. Gently pinch the tip of the capsule so as not to let the powder escape. Then punch the capsule back into the mound of powder until the desired quantity or weight is achieved. Then, weigh each prepared capsule to verify the amount of drug using a digital scale or Class 3 balance. You may remove or add powder at this time to adjust the weight. Always begin with approximately 10% or 2 capsules worth of extra prepared powder. When choosing the correct capsule size, it's general practice to use the smallest size capable of holding the compounded preparation. Place the exact number of capsules on the slab or parchment paper. This ensures that the prescribed number is made and that there will be no contamination to the bulk capsule container from the prepared formulation.
When mixing fluids, you may do one of two things: stir or pour back and forth. Stirring, while adequate, does not always allow for a completely homogeneous mixture. Pouring back and forth can produce a more homogeneous mixture by allowing gravity to intervene and mix the fluids using kinetic energy. Carefully and continually pour the fluids back and forth between the two containers to ensure a proper mixture. When first mixing fluids, use caution. Pouring can cause splattering, so never pour the liquid used for dilution, also called the solvent, into the active ingredient, as this may cause the active ingredient, also called the solute, to splatter. If both ingredients are caustic or harmful, use caution and wear appropriate safety gear to protect yourself from exposure.
Creating a suspension means incorporating a powdered or granular medication into a suspending agent in which the medication is insoluble. The powdered medication may be triturated tablets, granules from a capsule, or readily available powder. The suspending agent used in the compound is dependent on the active ingredient used. Suspending agents include commercially made products like sorbitol or sodium bicarbonate, or a pharmacy may create their own base or use simple syrup as a suspension agent.
Emulsions are typically made when one ingredient does not readily combine or dissolve into another. For example, pastes such as zinc oxide are emulsions. An emulsion normally contains two ingredients that don't mix with one another. Yet by using a suspending agent, these two ingredients can be suspended or dissolved into the compound. For example, zinc oxide powder is levigated with mineral oil to decrease the granules and allow for better suspension into the ointment base. In this example, petroleum jelly is used as the base. Similar to suppositories, the method of shaping hard lozenges or trochets is to use molds or dose cups. The medication is added to a base solution that has been heated. To make a lozenge base, you will need some common cooking utensils and ingredients: a hot plate, a saucepan, a digital thermometer, sugar, light corn syrup, distilled water, flavoring, food coloring, cooking spray. Stir the base or solution and carefully add the medication to create a homogeneous mixture. Pour the mixture into the molds or dose cups. Allow the lozenges to harden.
Hard lozenges are often made into the shape of lollipops or medication sticks using molds. To make medication sticks, use the method for making hard lozenges and just place a stick in the mold halfway through the setting process. Medication stick molds are also available. Using a medication stick is a great way to aid in administration compliance with children. It's just like sucking a lollipop.
Suppositories should be molded with the application site in mind. Improperly shaped suppositories could cause patient discomfort or harm. The use of suppository molds is helpful to ensure uniform size and shape. To use a mold, mix your suppository preparation and pour into the mold. Do this slowly at room temperature to prevent formation of air bubbles. Clamp the mold together and let the preparation solidify. Once solidified, carefully open the mold, trim the excess, and individually wrap each suppository in foil.
You now know what non-sterile compounding is, the various forms it can take, the equipment used, the techniques to apply, and the packaging and storage requirements. If you need to review a section, just click on the Scene Selection button on your DVD menu and choose the appropriate section.
We hope you've enjoyed learning about non-sterile pharmaceutical compounding and wish you all the best in your career.